Throughout the Vietnam conflict, United States Navy aerial reconnaissance aircraft have been facing a major test of their capability. Their performance has been outstanding. Flying mission after mission through what is recognized as the heaviest concentration of anti-aircraft defenses the world has ever known, Navy pilots have consistently brought back vital information on enemy activities, movements, and result of strike missions. Because of the high-risk environment, substantial losses of aircraft and aircrews were sustained. To reduce this costly attrition of lives and resources, a requirement was established for an unmanned reconnaissance vehicle, organic to the fleet, and directly responsive to the task force commander to supplement the manned reconnaissance forces. In response to this requirement, on November 4, 1968, the Navy awarded a contract to the Ryan Aeronautical Company for design and fabrication of the Model 147SK Special Purpose Reconnaissance Aircraft. 10 of these drones were delivered for a Navy Operational Evaluation Program. The 147SK drone results from technology and experience in unmanned aircraft amassed by Teledyne Ryan Aeronautical during the past 20 years. It is an evolution of the BQM-34A Firebee target drone that has been operational in the Navy since 1959. Teledyne Ryan Firebee drones, currently operated by the Navy, can be air-launched, ground-launched from a land-based zero-link launcher, or surface-launched from a seagoing platform. Mission complete, the drone is recovered by a two-stage parachute system and may be retrieved from the water by helicopter or boat, from land by helicopter or truck, or in midair by a specially modified helicopter. Following refurbishment and pre-flight checks, the drone is ready for its next mission. These same operation and maintenance practices have been applied to the 147SK Special Purpose drone. This new Navy reconnaissance vehicle is 28.5 feet long and has a wingspan of 14 feet. It is powered by a Continental J69 T41A turbojet engine, developing 1,920 pounds of thrust at static sea level. An aerial camera is housed in an environmentally controlled nose section. The Fairchild F415Y panoramic camera has a 3-inch f2.8 lens with 1,800 feet of 70mm film. It provides horizon-to-horizon coverage for a longitudinal distance of 155 nautical miles. This camera has automatic exposure control and image motion compensation and provides 60% overlap. At a nominal operating altitude of 1,500 feet, ground resolution of less than 6 inches at nadar is achieved. To maintain accurate target coverage, a navigation system composed of an MA1 compass, a Doppler navigator, a digital programmer, and an automatic flight control box is incorporated in the drone. This system has a 3% of distance traveled navigation accuracy when flown hands-off during the pre-programmed portion of flight. Prior to entering the programmed flight mode, the vehicle is flown under secure, remote manual control using the VRW-29 radio receiver, APX-71 L-band IFF transponder, and Dorset TM-431 telemetry transmitter. The vehicle is surface launched, using the Mark 23 Mod O ASROC booster, delivering 11,000 pounds of thrust for 4.4 seconds. Successful recovery of the drone is a vital aspect of the system and is accomplished using the mid-air retrieval system, MARS. This technique assures timely information retrieval, minimizes equipment damage, and radically reduces the time required for the maintenance and turnaround cycle. Under the guidelines of the Chief of Naval Operations, and within the parameters of the Operational Evaluation Program, the 147SK system and its 21-man detachment deployed to the Western Pacific Theater on the carrier USS Ranger CVA-61, following flight test demonstration aboard the USS Bennington and at the Naval Missile Center, Point Mugu, California. For operations in the combat environment, the 147SK is surface launched from a mobile launcher located on the flight deck or elevator forward of the island structure. At launch, a remote control officer in the Combat Information Center stabilizes the vehicle on a predetermined heading, altitude, and airspeed. He then passes control to a remote operator in an E-2A aircraft which has been modified for drone track and control. By painting the coastline or other identification points and tracking the 147SK, the airborne remote control officer guides the vehicle to a pre-selected geographical reference post-in point. As the vehicle crosses this point, the programmed covert segment of the flight begins and the radio receiver, telemetry, and tracking equipment are secured. During the hot phase of the mission, the camera is automatically controlled to operate and photograph the pre-selected targets. Once the target run is completed, the vehicle ascends to a higher altitude for egress. After leaving hostile territory, radio, telemetry, and tracking systems are activated by the programmer, and positive control is reapplied by either the airborne or shipboard controller. At the intended recovery point, the controller initiates recovery, and the helicopter accomplishes mid-air retrieval. The film is then delivered to the Task Force Commander at the Integrated Operational Intelligence Center for processing and interpretation. The 147SK is then recycled for further mission assignments. Operational evaluation has confirmed that the total 147SK system will provide useful and timely information to the Task Force Commander, effectively benefit the manned striking forces, and realistically complement the manned reconnaissance forces. It further demonstrated the capability to launch and recover the drone without interrupting normal carrier cyclic operations. Having attained these objectives, added capability and growth features can be added to enhance versatility with a resultant increase in effectiveness. This can be done by taking advantage of proven developments from other reconnaissance programs and technological advances in sensor capability. A forward oblique camera can be added to complement the vertical camera installation. A data link system can also be added for transmitting information on a real-time basis, either by direct downlink or via airborne relay. The data link can be interfaced with a television system whose imagery can be monitored in real time or stored on videotape for later viewing. By augmenting the F415Y camera with a TV data link, navigation updating can be achieved or en route selective retargeting accomplished. Probe systems can be used for night reconnaissance. A laser and infrared sensor systems can be sanitized and interfaced with nose mounted and used for covert night operations. In a number of these systems, the imagery can be recorded on board the drone for later retrieval, or transmitted by a data link to a ground or airborne receiving station. Other developed and proven systems, including electronic warfare chaff dispensing pods and wing pylon-mounted fuel tanks, can be added to meet a variety of mission requirements. The incorporation of system improvements and the application of new equipment and concepts being developed by Teledyne Ryan Aeronautical will continue to provide the United States Navy with advanced reconnaissance systems producing timely and effective intelligence.